Hi everybody, welcome to my new channel. I will be doing mathematics from grade 10 to grade 12 on all different levels, reteaching and reinforcing and moving into more difficult examples for those of you who need it. And I hope that you will find something very beneficial from what we are about to do. Let's get started. Today we're going to start reductions from scratch. You've all, I'm sure, heard of your CAST diagram, or else it's known as all students take coffee, first, second, third, fourth quadrant. You will notice that if the name is written there, then that is where that ratio is positive. For example, tan is positive in the third quadrant and the first, because everything's positive in the first quadrant. If the name does not appear there, it is negative in that quadrant. Right, very important that you know that we work from the x-axis upwards with a right angle triangle and downwards with a right angle triangle to get the formulas of theta, 180 minus theta, 180 plus theta, and 360 minus theta. So those are your standard formulas, and we use them to reduce big angles into small angles. Right, so let's go with the first one. 180 plus is a third quadrant formula, and in the third quadrant, sign is negative and stays as sine theta. Right, the next one. 360 minus is the fourth quadrant, where tan picks up a negative and remains tan theta. And finally, 360 minus is the fourth quadrant, where cos is positive and remains theta. Right, the next aspect is to have revolutions that we have to then take back to the CAST diagram, to the 180s and 360s, not a 540. So the easiest thing to do there is to take a pencil. Whoopsie, that doesn't look like much of a pencil. Take the 540, throw away a revolution, and you will be left with 180. Keep the minus theta. So 180 minus is second quadrant, where sine is positive. So your answer there is sine theta. So we have broken it down from a revolution. By throwing away a revolution, we landed in the second, and then once we landed in the second, we had to go to the first quadrant. Right, the next one is again a revolution. It's a negative revolution. We don't have a formula negative 180, negative theta, and please be very careful making up your own rules here. What you need to do is say the negative theta stays at the back. Add a revolution to negative 180 and you will get positive 180. Right, and then 180 minus is second quadrant, where tan picks up a negative. Okay. Right, the fourth part we need to look at is now jumping over to our co-function diagram. A co-function diagram uses the same all students take coffee or cast signs for the ratios, but the difference is we are now doing right angle triangles from the y-axis. So every time there is a sine, it changes to cos, and every time there is a cos, it changes to sine. And fortunately, we don't have to do cofunctions of tan. Right, so let's have a look at this one. Right, 90 minus is in the first quadrant. In the first quadrant, sine is positive and changes to cos. So there are two things you have to look at. You have to look at what quadrant you're in, and if you are using 90 minuses and 90 pluses, then you must take the originals quadrant. Right, what I mean by that is, let's look at the next one. 90 plus is second quadrant, where cos is negative and changes to sine. This one here, 90 minus is cofunction, it's off that table. 90 minus is going to be the first quadrant, where cos is positive and changes to sine. Right, and then just to give you one extra, it's not in the syllabus, but I think it's a good idea to know it because it does make trig easier. If you have got a sine of 270 plus theta, right, that is in the fourth quadrant. So sine in the fourth quadrant here, fourth quadrant, sine is negative and then changes to cos. So you must take this sign, positives and negative signs, from the original question. Right, we are now going on to the revolutions. The way to identify a revolution is that the theta comes to the front. Not every single one is a revolution, but this one is. So negative theta, put it at the back, so at least it's following the tables that we have. And then take the minus 180 and add a revolution of 360, and you will get 180 minus, and then you are back in your cast diagram. So that is sine in the second quadrant is positive. Right, this one here is a revolution. You can do it a few different ways. So the first thing we can do is say, put the negative theta at the back and add a revolution of 360 over here, and you are left with tan of negative theta, which we did over here, and that would be tan in the fourth quadrant, which is negative. Right, so again we've got negative revolutions, so I'm going to keep the sign. I'm going to put the negative theta at the back, and I'm going to add a full revolution, which will make me to positive 270, and I'm going to put that in the front. 270 is in the third quadrant, where sine is negative and changes to cos. So that's cofunctions with revolution. Right, we are going to carry on. We have got another reversed bracket, so it's going to be negative theta on the end and take the 180, add a revolution to negative 180 and you'll get positive 180. And you then have got cos in the second quadrant, which is negative cos theta. Right. Right, the final question. Here again, it is reversed. I'm going to do the negative cos to the back. And I'm going to add 2 revolutions to get this to be 180 degrees, which I'm going to bring to the front. So it's 180 minus theta, and that is going to be cos in the second quadrant. Cos in the second quadrant is negative cos theta. Right, I hope you've learned a lot from this. We have not done any big major questions from tests, but we have gone through 90% of the build up to those questions. Right, hope to see you at the next lesson and have a good day. That's it, and I hope you found this lesson very helpful. Please subscribe to get regular updates on future videos and leave a like and a comment. And if there's something in particular you'd like me to cover, please let me know. And please share with anybody out there who you think would find these lessons beneficial.